Our world constantly requires faster response times, smarter applications, communication on a larger scale. Batch processing internet applications are limited and limiting, whereas future internet applications will need to be servicing high interactivity in real time. Think of applications in different domains of everyday life in which real time is critical, is required, and/or proves to be cost-effective. A traffic light sensor that sends information to be analyzed in real time and thus making the decision of turning red or green before the car ever stops. A virtual reality environment, such as an online interactive game where thousands of users concurrently log in, acquire more ammunition, and use intense graphics. But also consider the benefit of this real-time approach on traditional applications that are computationally intensive, such as object detection in a complex environment. The more complex the environment, the more resources are required to sustain the desired accuracy levels. But how does this work? As applications' real-time demands grow, additional resources need to be provided on demand during runtime. This calls for fast, low latency, and reliable automation. But what does automation mean? We know that there is a need for providing more resources during runtime, knowing when to provide these resources and ensuring that resources are provided on time and with no effect to the application's execution. We take out of the equation any human manipulation and thus enable real-time response during runtime through automation. Let's consider a large-scale industrial environment. Here, object detection and process identification make it possible to guarantee quality, provide better supervision services, ensure security and safety, and improve production scheduling. Yet, up until now, the camera feeds are captured and analyzed at the end of the day, making any improvement come after the fact, not as things happen. We have managed to eliminate this delay by enabling the application to respond in real time. So, how did we do that? Welcome to the cloud. Cloud computing infrastructures enabled us to facilitate real-time and interactivity without major modifications in the application domain, and efficiently adapting resource provisioning to the application's dynamic demands. Yet for this to work, there need to be a set of mechanisms that can provide quality of service guarantees. These mechanisms, known as service management mechanisms, incorporate approaches for orchestration, for managing the execution of non-monolithic applications, adaptable monitoring, for collection and aggregating monitoring information from application and infrastructure levels, evaluation, for enabling runtime adaptability through provisioning policies. These mechanisms were initially developed in a previous European project called IRMOS. In IRMOS, we evaluated the functionality and effectiveness of our approach in a small-scale environment, but we wanted to evaluate in a real cloud environment that would enable the provision of quality guarantees, since instances of the orchestration and the monitoring mechanisms would be deployed in each and every virtual machine included in the application services. However, is this architecture still valid and efficient when scaling from dozens of machines to hundreds, as is required by the application during runtime? BonFIRE offered a large-scale facility with not only the resources, but the monitoring and the control that was required to understand how to offer guaranteed quality of service. It allowed us to experiment with a multi-site cloud and test the network conditions between them. We could experiment, understand, and evaluate the effectiveness of the proposed hierarchical architecture in large scale, with resources geographically distributed across different sites and with varying network conditions to identify whether and to what extent they affect the operation of the service management mechanisms. Through experimentation with BonFIRE, we were able to validate the effectiveness of these mechanisms. The key point being that the infrastructure dynamically adapts to user and application demands. To test it, we used video sets from Nissan's production line. We adapted a computer vision application into real-time cloud processing with successful results.